Hello, good morning student. How are you? I hope you all are happy and healthy at home. So, what did we learn yesterday or what did we discuss yesterday? We discussed about the protection and deprotection of aldehyde and the ketone group. What are the group used to protect the aldehyde group as well as ketone group? How the protection and deprotection can be done with in what condition and in what condition it is removed, that type of the thing we have seen in the what is that protection and deprotection of aldehyde and the ketone. So now we are going to discuss about aldehyde and ketones can be protected as acetal and the ketos. Open chain we have already seen. Now we are going to learn that is by using the 1,2-diol or 1,3-diol, and there will be a formation of cyclic type of the compound that we are going to learn over here. Let us begin with first one is aldehyde. As we know that the general formula of aldehyde is RH. This is a general formula of aldehyde. When it is treated with this one HO, then this OH in presence of H plus, right? This is a 1,2-diol. It is known as 1,2-diol or ethane, 1,2-dihydroxyethane we can call it. And the resulting compound we are going to get here O, then O, this one and H. This is a protection of carbonyl group by using 1,2-diol. We are getting here is a formation of cyclic acetal protection, this one, right? Cyclic acetal protection. And this cyclic acetal protection can be deprotect under acidic condition if you use here and acidic condition, and this cyclic acetal protection is a very stable under oxidizing reagent as well as reducing reagent, or in a basic condition it does not get interfere. So we can carry out the transformation at desired at other site of the other reaction site, and we will get the desired product, or we would get the desired product. Now after the deprotection, what you are going to get? You are going to get the aldehyde group as it is. So RC double bond to aldehyde, that is a deprotection. So now let us look at the mechanism, how the mechanism of protection, how it takes place here. Let us see here R, C, double bond O, then H. Now it will be treated with in acidic medium, lone pair which is present on oxygen atom easily attack on that proton. We are going to get R, C double bond O, H and H. Look at oxygen atom has a 3 bond. Therefore, I am putting positive charge on the oxygen atom. Now, if you compare between these two carbonyl carbon, which one is a more electrophilic in nature? This carbon becomes more electrophilic in nature than this carbonyl carbon, and therefore now there is a attack of this one HO. You can write this OH now is going to attack on this carbonyl carbon, and positive charge get neutralized. You are going to get here R, OH, then this H, C here O, I am writing this one OH over here, right? Now here is a positive charge present on this, and now what is going to happen? There is a loss of proton, minus H plus takes place over, because when the positive charge comes on that oxygen atom, that species become highly unstable. It trying to attain the stability by losing proton, and you are going to get here R, C, OH, H, then O, here CH2, CH2 and OH. For sake of convenience, I am writing this molecule in this manner. Now again H plus which is lost over there, this hydroxyl group can pick up that proton or that lone pair attacking on that proton. What do you get? R, C, OH twice, then H, this O, CH2, CH2 and this OH. Now positive charge on it, because when positive charge comes, it becomes as a highly unstable. The lone pair which is present on this oxygen atom, it is attacking on this carbon atom. There is a elimination of water molecule, and what do you get here? R, C, here H, this O, then CH2, CH2 and this oxygen atom and H, positive charge over there. Then again this species become as unstable, and finally you will get R, C, H, O, CH2, O and this CH2. This is a protecting, this is the mechanism of protection. Now move on to the deprotection. Deprotection can be carried out under acidic condition. Let us see how it takes place, the mechanism of deprotection. Now let us see the mechanism of deprotection. Mechanism of deprotection. Mechanism of deprotection. Let us see this one. R, C, O, then CH2, O and this H. In presence of the acidic medium, this lone pair which is present over there attacking on that hydrogen atom, we are going to get R, then O, CH2, this O and H. Now this one H. Look at this oxygen atom. Again there are 3 bonds. Therefore positive charge comes on it, and now the water molecule H2O which is present over there in our cup, it can break the bond like this. You will be getting R, C, then O, then CH2, this OH, and now here OH you can write here like this, then H. Finally this sigma bond forming as a double bond over here, not this one. Before that, one step is there. Here positive charge, the lone pair which is present on this oxygen atom will pick up this proton, and you are going to get here this one R, C, O, this CH2, then OH, 1H. Look at again this oxygen atom carrying as a positive charge, because there is a 3 bond, and now this one is a OH like this. Now after that what is going to happen? This sigma bond forming as a double bond over there, pi bond, and this positive charge get neutralized. Finally you are going to get the product RC double bond OH. This is a acetaldehyde back over here. So in this way we have seen the mechanism of protection as well as deprotection for the cyclic acetal formation. Similarly, for ketone, let us look at as a second one is a ketone, right? Now, let us see for ketone. Let us take down the starting compound is a ketone, R C double bond O R dash, that will be treated with 1,2-diol. This is 1,2-diol, which is which one? This one, HCH2 OH in presence of H plus. You are going to get R C double CO CH2, this one, R dash. This is known as a cyclic kettle. This is known as a cyclic kettle formation, or which is known as 1,2-dioxylane, or dioxylane, 1,2-dioxylane. This is also known as 1,2-dioxylane. If 1,3, that is called as 1,3-dioxane. Instead of that, we will see later on. But here this one. And now, and this can be removed under acidic condition. H plus, you will be getting here R C double bond O R dash, right? So this is the ketone regenerated here. Now let us look at as a mechanism of protection. Mechanism of protection. First one, R C double bond O R dash. First, it will be treated with acid in acidic medium, lone pair which is available on nitrogen atom attacking on that proton, and you are going to get R C double bond O H positive charge and R dash. As I already told you that if you compare the electrophilic nature of this carbonyl carbon and this carbonyl carbon, which one is a more electrophilic in nature? This one is a more electronegative in nature, electropositive in nature than this one, and therefore now we can take down here 1,2-diol. Let us see here HO, then CH2, this OH. Now the lone pair which is present over there is going to attack on that carbonyl group, and this positive charge get neutralized, and the resulting compound we are going to get here RCOH, then R dash, then OH, CH2, and then this one OH. Positive charge comes on the oxygen atom. Whenever positive charge comes on the oxygen atom or on a heteroatom, that organic species becomes highly unstable. It trying to stabilize it losing the proton in this way, and you will get ROH, then O, this R dash, then CH2, and this OH. After that, what is going to happen here? H plus, because we are using acidic medium, the lone pair which is present on hydroxyl group is going to attack on this proton, and you are going to get here RCOH2 positive charge over here, R dash, then this O, then CH2, this one is a OH, and finally what is going to happen? The lone pair which is present on this hydroxyl group is going to attack on this carbon atom, and this now hydroxyl group is a bad living group. When it is converted into that type of the unstable species, that becomes as a good living group, and that losing as a neutral molecule like as a water molecule, and you are going to get here R, then R dash, finally O, then O, CH2 and CH2, and here H plus, positive charge comes on it, then it losing the proton and get the stable compound formation RC, then R dash, here O, then CH2. This is called as cyclic kettle formation. Cyclic kettle formed here. So in this way we can protect. This is a representation of the mechanism of cyclic kettle. Now let us move on to the next one, that is a mechanism of deprotection of cyclic kettles. Deprotection. Let us see here cyclic kettle for deprotection. Here R, then C, O, CH2O, this R dash, right? It is so simplest now. This is a 5-membered ring. Now it is get deprotected under acidic condition. The lone pair which is here is attacking on that proton. You are going to get R, C, then O, CH2, O, H, this one, R dash. The positive charge comes on that oxygen atom. Whenever positive charge comes on that oxygen atom, that becomes as a highly unstable. It neutralized by bond breaking, so that you are going to get here RC, then here O, CH2, then OH, then R dash. The positive charge comes on this oxygen atom, and now the water molecule H2O is going to attack over there, and you are going to get here R, then C, O, CH2, OH, then R dash, and here is a OH. Now the proton H plus, this lone pair which is present on it is attacking this lone pair, attacking not this one. Let us see here the lone pair which is present on it, what do you get here? Here the lone pair is attacking on that proton, and finally you will get R, C, then O, next one, this OH, proton attacking over there, positive charge here, R dash, then OH. And as I already told you that whenever there is a positive charge comes on that oxygen atom, that species becomes highly unstable in nature, and this sigma bond move like this, forming as a double bond, and this molecule lost, and you will get the final product is acetone here, RC double bond O, R dash. In this way we can this the cyclic kettle formation. Now what is remaining here? Instead of 1,2-diol, for example, let us see, suppose here general protection and the deprotection. Just now we have seen as a mechanism, the aldehyde group and the ketone group, RC double bond O, H, this is the aldehyde group, as well as ketone group, as we know that RC double bond O, R dash. This is the aldehyde, and this will be the ketone, right? One is aldehyde and one is ketone. Just now we have seen 1,2-diol, or we can use, instead of 1,2-diol, we can use 1,3-diol as well. This one OH in presence of H plus. Similarly, here also this is called as a 1,3-diol, 1,3-diol or 1,3-propane dihydroxy or 1,3 diol we can remember here, and here HO, then this one OH. Now this also in presence of acid, what do you get here? In a previous case we have considered as a 1,2 diol. Here we are considering the 1,3 diol. The result is the same in the case, only the position of hydroxy group is different. So R, C, O, then this CH2, then O, there becomes as a 6-membered ring, and as we know that this is a cyclic ketone formation, cyclic acetal protection, this one protection. And now in this case R, then O, this O, this one, and R dash, this is a cyclic ketone protection, and mechanism is a similar whatever we have seen for 1,2, it remains same, and the deprotection, mechanism of deprotection also is the same, and this group can be removed under acidic condition H plus. The resulting compound will be RC double bond O, R dash aldehyde, and here RC double bond O, R dash ketone here. So this is the mechanism which we have seen for 1,2 diol, it remains same. Now move on to the next one. So let us see here what we are going. First for aldehyde, let us see some of the thiol formations, right? Thiols are there that we are going to learn here. Now thiol, how they are used for the protection of aldehyde and the ketone. Let us see here, as we know that the general formula of aldehyde is a RC double bond O H, right? And that will be treated with thiols, 1,2 thiols or 1,3 thiols, doesn't matter. So let us see here 1,3 thiols, H, S. Then let us see here this one, S, H, in presence of the H plus. This is a 1,3 thiol, right? This is a 1,3 thiol. In case of diol, we already learned that one. And now this is a thiol, R, C, then S, then this 6-membered ring formed there, H. This is a cyclic thioacetal formation, acetal protection, right? Protection and deprotection can be carried out under this one, mercury chloride in presence of cadmium carbonate, CO3. This is a reagent used for deprotection of this one. So what do you get here? You are going to get here RC double bond O and HO there. Aldehyde get deprotected by using this one. Now the mechanism for cyclic thioketal is the same whatever we have seen over here, but here HgCl2 for the deprotection it can be carried out and you will get as this one. Or if you use here that H2 in presence of Rane nickel, what you are going to get? This is a Manzingo reaction, or it is the reduction reaction. So desulfonation takes place and you are going to get resulting product is RCS3 over here. Hydrocarbon you are going to get, carbonyl group is completely get so that you will get as this type of the product. Mechanism, whatever mechanism we have seen for 1,3 diol or 1,2 diol, it remains as it is. Once you know the one mechanism, you can able to draw the further mechanism. Now let us see another one. As we know that another one is a R, C double bond O, R dash, that will be treated with the same reagent HS or 1SH. Here I am specifically mentioning as a 1,2-thiol, 1,2-thiol here. In a 1,2-thiol, what you are going to get? You are going to get R, C double R, then yes, this one, yes, 5-membered ring you are going to get here. And if you, for the D protection, we can use HgCl2, mercury chloride in presence of cadmium carbonate. The resulting product obtained will be RC double bond O R dash ketone here. If this is known as a cyclic thioacetal, this is a cyclic thioacetal formation, not cyclic thioketal. This is acetone, therefore cyclic thioketal formation, and we are getting this. Instead of this, if you use the Rane nickel H2 in presence of Rane nickel, what do you get? The desulfonation takes place and you will get R C double bond O R dash. This is the compound you are going to get over there. And now the solvent you can use to carry out this reaction, we can use boron trifluoride in presence of ether or DCM. These are the solvent you can employ for this reaction to carry out. I think these are some of the reagent which can get protection and the deprotection. Another one, hemithioacetal, can be possible in presence of this. As we know that these are the starting material of what is that? Aldehyde and the ketone, as we know that. And when this hemithioacetal, how hemithioacetal can be carried out by using the reagent like alcohol in presence of as you know that trimethylsilyl chloride in presence of pyridine, the resulting compound is obtained is a semi-thioacetal, hemithioacetal like this. Here R, then O, then yes, this one and H. This type of the compound you may get further here, and then R, not I think this is a hemiacetal and the thioketal formation. If you use here open chain, this one is under first one. What is the reagent? Yes, here is a HO, CH2 and SH in presence of trimethylsilyl chloride, and the pyridine is used there, so that you will get as this type of the formation. And deprotection can be carried out by using NBS or tetrabutyl ammonium fluoride, and so that you are going to get R C double bond O, then H. Similarly, if the same reagent if you use over here, you will get the resulting compound. Here let us see here, suppose is R C double bond O R dash ketone, that will be treated with HO, then CH2SH in presence of H plus and the ZnCl2. What do you get? You are going to get here R O, then CH2, S, then R dash, and that can be removed under this reagent, that is NBS, N-butyl succinamide, and or we can use tetrabutyl ammonium fluoride. Ammonium fluoride, these are the reagent can be used for the deprotection of this, and you will get RC double bond O R dash. So I think with this we have completed the protection and the deprotection of aldehyde and the ketone, how they form acetal as well as ketone with the suitable example. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.